Hello again. This is Math 1120 coming to you from the College of DuPage, and this is the continuation of the lecture entitled Sampling Distributions and Confidence Intervals. And in this segment, we're going to talk about sampling distribution for a proportion. Now, in our textbook and in the VCM lectures, we have talked a bit about this, but it has not been covered in the Decision Through Data video series. Let's begin with the definition. Suppose that the random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic, like you could smoke or not smoke, you could be Republican or you could be Democrat, so on and so forth. The sample proportion, denoted p hat, and that's the way you read this, the little caret is called hat, is given by p hat is equal to x over n, where x is the number of individuals in the sample with a specified characteristic. The sample proportion, p hat, is a statistic. Anything in a sample is always a statistic that estimates the population proportion, which is p. Let's look at an example. So the Harris Poll conducted a survey of 1,200 adult Americans who vacation during the summer and asked if they plan to work while they're on vacation. Of those surveyed, 552 indicated they plan to work. Find the sample proportion. So you use the formula p hat is equal to x over n. You take the 552 and divide that by n. You do the calculation with the calculator Excel and get 0.46. So based on this sample, the point estimate that one would have is that 46% of adult Americans who vacation during the summer plan to work while on vacation. And one of the things, if we do a bunch of examples and empirical measurements, we notice that the following things emerge. As the size of the sample increases, the shape of the distribution of the sample proportion becomes approximately normal. The mean of the distribution of the sample proportion equals the population proportion p. And the standard deviation of the distribution of the sample proportion decreases as the sample size increases. We saw the same thing happen with the discussion we had about the sample mean. Although the proof is beyond the scope of this book, this is a result we're going to be using a great deal. For a simple random sample of size n with population parameter p, the shape of the sampling distribution of p hat is approximately normal provided that n p times 1 minus p is bigger than or equal to 10. The mean of the sampling distribution of p hat is mu sub p hat equals p, and the standard deviation of the sampling distribution of p hat is sigma of p hat equals p times 1 minus p all by n and the square root of all of that. Let's do an example here. So based on a study conducted by the Gallup organization, 76% of Americans believe the state of moral values in the United States is getting worse. So suppose we get a random sample of n equals 60 Americans and determine who believes the state of moral values is getting worse. We ask them the question, is it getting worse or not? Describe the sampling distribution of the sample proportion for Americans with this belief. Well, since we are dealing with a finite population, albeit it's big, you have to have the sample size less than 5% of the population, and this is the one we normally check, np times 1 minus p is at least 10. And so, if so, then this is normal with mean mu sub p equal p, mu sub p hat equal p, and standard deviation sigma sub p hat equal the square root of p times 1 minus p all by n. Well, since the United States has over 300 million people, the sample size of 60 is less than 5%. And also, if we do this calculation here, we will get that this is equal to a number that's bigger than or equal to 10. So that means we can declare this as approximately normal. This is the mean, and the standard deviation can be calculated this way, and we will get 0.055. Here's one for you to do, number 7. You know what to do. Let's see how you did. Well, the sample size, if we take this times 25,000, is this, and so the sample size n is certainly less than that number, so it's less than 5% of the population size, and n, p times 1 minus p is equal to, we do the calculation, 120 is certainly bigger than or equal to 10. So we can declare that this distribution of p hat is approximately normal, and mu sub p hat is equal to p is equal to 0.4, and the standard deviation is sigma sub p hat is equal to p times 1 minus p over n, square root of all that. We put in the numbers, and we get is approximately equal to 0.022. Now we're going to compute probabilities using that sample proportion. According to the National Center for Health Statistics, 15% of all Americans have a hearing problem. So what we do is we, in a random sample of 120 Americans, what is the probability that at most 12% have trouble hearing? Well, first we're going to check to see if the sample size is less than 5%, and since there are over 300 million people in the U.S., the sample size is definitely less than 5%. Also, we're told that p is equal to 15%, and then this is equal to 15.3, which is bigger than or equal to 10. So we know that this is approximately normal, and we know the mean is mu sub p hat is equal to 0.15, and the standard deviation sigma of p hat is equal to this by our formula. And we want to know the probability that a random sample will result in a sample proportion of at most 12%. So what we want to know is the probability that p hat is less than or equal to 12%. Well, we know this is a bell-shaped curve. We know the mean. We know the standard deviation. And so what we're going to do is we're going to be using the z transform. So we'll change p hat to the normal, standard normal this way. And notice, see, here we're dividing by 120 in the denominator as we do that calculation, and we get minus 0.92. Now this means we're almost one standard deviation less than the mean. And so what we can do is we can use our normal tables, looking up at z equal this, and we find the probability is this. So what that means is that the probability that p hat is less than or equal to 12 is equal to this number. Now, let's go to part B. So suppose we're doing this in a random sample of 120 Americans who regularly listen to music using headphones, results in 26 having hearing problems. Now that means that this sample, p hat is equal to 26 over 120, and so that p hat is equal to 0.217. So you see what we're doing is we're taking this number and we're going to compute a probability. So we'll change it to a normal 0, 1 using the z transform. And notice we're using the fact that there's 120 in the sample right here, and we get a positive 2.06. Now what this means is that that measurement is a little bit over 2 standard deviations larger than the mean. Now you can use your table in your book, and you should check this calculation, 2.06. You get this as a probability. Now you did have to say, oh, I found really in my table I found this, and I had to subtract it from 1. And so when I do that, what I will get is that the probability that it's bigger than or equal to that is this, and you could have subtracted it from 1 as well. Now, what would one conclude? Well, you could just say, oh, I just happened to get a sample of people who are having hearing problems, but more likely what happens is that the population proportion of Americans with hearing trouble who regularly listen to music using headphones is more than 50%. That is, this hurts your hearing. Okay, here's a problem for you to look at and work. I didn't put the little tag here, but you know what to do. Let's see how you did. Well, the sample size is less than 5%, and this calculation is bigger than or equal to 10. So we know that this distribution of p-hat is approximately normal. We know what the mean is, and we know what the standard deviation is. And in the problem, we're asked with part B to find what is the probability p-hat that we're less than 0.38, and we change that to a z-score, and we get that this is 0.3328. So about 32 out of 100 random samples will result in less than 38% who believe marriage is obsolete. And so that's not, and we could do the other parts of the problem too. I don't think I put those here. And when we reconvene, we're going to talk about confidence intervals then for a proportion. Take care.